Hi everyone, I just want to give a quick overview of what this week's experiment is about. Um, the determination of KSP, which is solubility product constant equilibrium, and we are going to determine this KSP from using pH measurements. So we'll review a little bit of the principles of solubility, focusing on solubility of hydroxides, and also understand how pH measurements can be used to determine the concentration of species in solution, which in turn will help us to determine the KSP of the solution. Therefore, let's get started. KSP, which is the solubility product constant, is an important concept that help us to predict whether precipitation occurs when a cation and an anion is combined. So here we have an example of the silver cation and chloride anion, and when they are combined we can see that there's a solid formed here. So the KSP is a value that determines the precipitation of this solid in a solution that contains this cation and this anion. And the expression for the KSP is basically taking the concentration of the cation in the solution and multiplying it by the concentration of the anion in the solution. Solids are usually not included in the equilibrium expressions because they are assumed to have a concentration of 1. Okay. So with our reaction today, we know that water is used a lot in solutions, and water has its formula is H2O, of course, and I will just write something here. And you know that with water there's one hydrogen ion and there's also one hydroxide anion. And with any hydroxide, for example, when we are dissolving a substance in water, we have to take into account the concentration of the hydroxide and the concentration of the hydrogen ions and the concentration of the hydroxide ions. And therefore with our experiment we are going to use the KSP concept where we have a starting concentration using a chloride solution, and then use the sodium hydroxide as the source of our hydroxide. And once we obtain our slightly soluble metal hydroxide, we will continue adding some of the hydroxide ions into this solution. And basically with any concept of equilibrium, when we have an addition of the reactants, for example, then we expect our equilibrium to shift to the left, right? And so for example with this metal hydroxide here, if we add more hydroxide ions, then the equilibrium will shift, forming more of the metal hydroxide, and that's where the precipitation occurs. And this enables us to calculate the KSP with the expression of the M2+, this is just the metal cations, and also the concentration of OH minus the hydroxide anions. And this is raised to power 2 just basically because you see this value here, the stoichiometric value 2 here. And so with our KSP calculations today, this is basically the important formula to keep in mind in determining the KSP for your for this experiment. And so how do we calculate the KSP? One, we of course say that we need to find the concentration of the cations in the solution, and we also need to find the concentration of the OH in the solution, and we said we are going to use pH measurements. Well, pH is related to the pOH, which will help us to find this number here. And then we have a starting value of the concentration of our solution that will enable us to find the number here. And these two should be multiplied together, and the OH concentration is raised to the power of 2 to go back to the KSP. And so let's see what happens. Alright, so with the experiment, we said we are going to take pH measurements when adding the sodium hydroxide. So sodium hydroxide, as we said, is the source of the excess hydroxide ions in the solution that enables our equilibrium to go back to the left and form more of the metal hydroxide, and causing the precipitation to be observed. And that helps us to also find, with the pH measurements, as I said, it helps us to determine the concentration of hydroxide ion as well. And we will see the formula relating pH to pOH and therefore the concentration of the hydroxide. So we say that our aim is to get the KSP, and we first have to know what this number is and what this number is also. And so while this says that we assume that the concentration of our metal cation is constant, so our starting concentration for the solution we used is 0.2 molar. So just assume that the M2 plus is this value right here. Okay, and then when it comes to the finding the concentration of the hydroxide ion, then we have to record our pH and then use this formula right here to determine the pOH. So for example, if my pH is at 6, then 6 plus pOH is 14, and my pOH would be 14 minus 6, which would then be around 8. And after I find my pOH, this is also how to relate pOH to the finding the value of the OH. So just take 10 raised to the power of the negative value of your pOH. So if my pOH, for example, was 8, then my OH would be 10 raised to power negative 8. And I hope this makes sense. So once you find this value, then just multiply it. Well, you have to raise it by the power of 2 here, just don't forget that, and multiply it by the 0.2 molar to get your KSP. And I believe that's the information that you need to help you figure out and understand the questions you're going to be asked in the